Now we're going to look at some composition of function problems. We still need to worry about the principal values here. So although it looks like in the first example that the sine inverse and sine would just cancel each other out, 5 pi over 4 is not a principal value. So we have to take it through the process. First, our reference angle is pi over 4. We want to think about what quadrant 5 pi over 4 is in. So remember, you can think about 4 pi over 4, and it's close to that, just a little bigger. So it's going to be quadrant 3, where it's negative. And then sine of pi over 4 is root 2 over 2. So we're doing sine inverse of negative root 2 over 2. Now, in keeping with what we did before with inverses, inverse sine answers would fall in the first and fourth quadrant, but be negative in the fourth. So since it's negative, we're going with the fourth quadrant. We're going to put the answer of negative pi over 4. So another way to look at it has to be between negative pi over 2 and pi over 2. Totally different answer than the one that we started with, or the angle that we started with, but falling in that principal value range. Next example, we have different functions, which means the reference angles will change as we go through. So we're going to start out with a reference angle of 60 degrees. We are in quadrant 3 again, so we're going to be negative for sine. So it's cosine inverse of negative, and sine of 60 is root 3 over 2. So again, really going back and reviewing all that unit circle stuff. Now for cosine of negative root 3 over 2, we're looking at the first or second quadrant, so it's going to be in the second. The reference angle we're using for this now switches. So if we had a reference angle of 60 for sine, for cosine, that same value is going to have that reference angle of 30 degrees. So we'll want to do 180 minus 30, which will give us a final answer of 150. Notice my answers are staying in the same units as the original problem, which we stated up above. That is a side note. You do need to know that and realize that anytime you're starting in radians, you should end in radians, or anytime you start in degrees, you should end in degrees. If it doesn't specify, like the next one, then it doesn't matter which one you decide to go with. Okay, so here we have tangent inverse we're starting with. So first or fourth, and it's negative, so we're going to go with fourth quadrant, negative angle, and that would be either negative 45 or pi over 4. So whatever you want to put for your middle step for that is fine. And then cosine of negative 45 degrees, well, we know we're in the fourth quadrant. Cosine is positive in quadrant 4, so it's going to be an answer of positive root 2 over 2. Let me just have a few more examples kind of similar to these. So let's kind of scroll down and look at some of those. We'll do the reciprocal functions in their own video. Sine inverse of negative 1/2. Again, first or fourth, so it's going to be fourth quadrant. And I can stick with degrees if I want to because it doesn't specify. So that's going to be negative 30 degrees. And then tangent of negative 30 degrees. Tangent is negative in quadrant 4. So it will also be negative, and that will be root 3 over 3. Again, choosing it from your chart or unit circle values. We're doing another tangent one, first or fourth. Tangent is negative in the fourth, so it's going to be sine of negative 45 degrees. Sine is also negative in quadrant 4. So sine and tangent kind of follow some of the same rules when it comes to the principal values, which is helpful. And that will be negative root 2 over 2. All right, and one more with these regular functions. Tangent of 135 is quadrant 2. Tangent is negative in quadrant 2. Another thing I didn't mention earlier, but remember all students take calculus, can help you with your positive and negatives. And 135 in that quadrant is going to be negative 1. Now you might need to think about for this, okay, where is cosine negative 1? Cosine is your x value, so 1, 0 here, negative 1, 0 here, and that happens at 180 degrees, since we were in degrees to start with. All right, so we have one more video to go that will look at reciprocal functions and a different type of way to approach the problems without using the exact values.